Okay, so we are going to continue down the rabbit hole that is stoichiometry. And our next installment is going to involve going beyond just predicting how much product we get based on a set number of reactants. We're going to go a step further and start identifying what's called a limiting reactant or limiting reagent. All right, so things we ought to be able to do pretty darn well by now is converting a known quantity to moles, or vice versa, balancing molecular equations, and then using mole ratios from the balanced molecular equation to convert from one substance to another. All right, so that's that basic stoichiometry that we've been working on. All right, but we're going to go one step farther and start identifying limiting reactants. Okay, and so what you have to understand here is reactants are not always mixed in exact proportions. So we've been kind of assuming, I give you, let's say we have 30 grams of magnesium in a reaction with hydrochloric acid, and I've just been telling you to assume you've got enough hydrochloric acid to use up all the magnesium. All right. So that's not always going to be the case, though. Okay. And so we're not always mixing things in their exact mole ratio proportions. All right. When the proportions are not exact, that means that one element or compound is limiting and the other one is excess. And what we're going to look at to try to figure that out is how do we know which one is limiting and which one's excess? Okay. But what we do have to understand is the limiting reactant is the one that determines the quantities of the products. All right, so let's consider a reaction between magnesium and hydrochloric acid. Right, so our reaction is going to be like this. We have magnesium and hydrochloric acid. It's going to yield magnesium chloride and hydrogen gas. All right, and we need 2 there, and that should balance us out. Okay, so there's our balanced molecular equation, right? And again, the way we ought to be able to read this now, based on what we've already learned, is that 1 mole of magnesium will react with 2 moles of hydrochloric acid to produce magnesium chloride in solution and hydrogen gas. Okay, what we have to consider now is how much are we actually starting with. So if we go with 7 grams of magnesium, right? So I start with a little 7-gram chunk of magnesium metal, and in solution I've dissolved 30 grams of HCl. How do I know which reactant is limiting and which one is excess? Okay, so the way we'll do that is step 1 there is we're going to calculate the moles of each reactant. So we've been doing this where we just calculate the moles of one of them. We need to calculate the actual moles of both substances, all right? So my moles of Mg will be equal to 7.0 grams Mg. There's 24.3 grams Mg in 1 mole. And that should give me 0.29 moles of magnesium. And for HCl, I've got 30 grams HCl. And there are 36.46 grams HCl in 1 mole. And that should give me 0.82 mole HCl. Okay, so there's step 1. I've converted both of those to moles. Now, what we have to do is we have to compare this ratio, the 0.82 to 0.29, to this ratio, 1 to 2, right? So, my exact ratio would be 1 mole of magnesium to 2 moles of HCl. We need to see if that ratio actually emerges comparing these 2 numbers. Okay, so our next step then is to turn this into a whole number ratio. Now, some of you guys are going to be good enough at just doing math in your head that you don't necessarily need to do this step. I'm going to do it anyways just to illustrate it, okay? So I'm going to turn my 0.29 to 0.82 into a whole number ratio, right? So the way that you do that is you pick the smaller one, which is 0.29, and divide both quantities by that. So 0.29 over 0.29, so that's going to give me a 1 over 0.29, and that's going to 2.83, okay, or 2.8, I guess. So again, what I'm looking for now at this point is whether the actual ratio that I have is going to match the ratio from the reaction, right? And so what I have is a 1 to 2.8 ratio, all right? So now I'm going to compare this ratio here to what I have up in my actual reaction, okay? And so what emerges is I have 1 mole of magnesium for every 2.8 moles of HCl. Now what that tells me, okay, is since my ratio up here in the reaction is 1 to 2, this ratio down here is 1 to 2.8. That tells me that the HCl is excess and that the magnesium is limiting. Okay, so again, what we do there is we take our given quantities of both reactants, we convert them into moles, and then we try to identify the ratio as a whole number if possible, right? So again, I turned that into close to a whole number ratio by dividing by the smaller of the 2 mole quantities, each value by the smaller of the 2 mole quantities. That gave me a 1 to 2.8 ratio. That tells me that in this case, I have 2.8 moles for every 1 mole of magnesium. So the 2.8 is greater than 2. So 2.8 is the excess. The 1 mole of magnesium is limiting. And why I need to know this is I have to use the limiting reactant to determine how much product I actually get. So essentially that means that the magnesium is going to run out sooner than the HCl, all right, because I don't have enough magnesium. So in this case, I would identify the 7 grams of magnesium as the limiting reactant, and I would use that 7 grams to determine how much magnesium chloride I get or how much hydrogen gas I get. Okay? And that also means that after that reaction is complete, there will be some hydrochloric acid left over in solution. We won't consume all of that. Okay? That about sums up the limiting reactants discussion, right? From that point, you just proceed on with your stoichiometry as you've been doing. It's just an added step in the beginning to try to determine which reactant's limiting.